That's fine. Okay, what my agenda for today is we want to finish up chapter 6, and then we're going to step into chapter 7 and talk about some of the things there. But we got to a portion of chapter 6 talking about different fruits that are it's in the fruit section of it, talking about the actual products that plants produce. We have a term called caryopsis, and that's not a term that you guys will normally use in your daily discussions. But it is a word that describes a lot of the foods that you consume. Caryopsis, it's a one-seeded fruit with a thin pericarp surrounding and adhering tightly to the true seed. That's what we're talking about with, excuse me, with a caryopsis. And examples of caryopsis: corn, rice, wheat, and barley are examples. And I venture to say that every one of you will deal with the products of caryopsis in your day, every day. If you have a cracker, if you have a biscuit, if you have corn, the true corn for in a meal, cornbread, all of these things. Rice. Your Oriental folks use an awful lot of rice. Mexican, a lot of your Mexican meals based on rice. The different components that go into our daily meals. Some of you, may have tasted beer. Barley is used in the manufacturing or the construction of beer. So, those are just examples of what we talk about with a caryopsis. Another fruit is a nut. And nuts are one-seeded fruits with thick, hard, stony pericarp. The examples there are acorns. They come from oak trees. A chestnut. Not very many chestnuts grown. There are some Chinese type varieties of chestnuts that have been brought into the country, but the old native chestnut that were common in the areas just west of where I sit, back in the 1930s, there were huge chestnut trees that covered the mountains here, and we had a blight that destroyed all of those chestnuts and took them out. But if you ever have an opportunity to walk and stumble through some of the mountainous areas west of here, and particularly a little north, if you go up into Banff and Highland County, you can see the remnants of the old chestnut tree. Sometimes there may be a log or a hollowed out log that may still be 4, 4.5, sometimes even 5 feet in diameter. Chestnuts were a staple to the timber industry. There's a lot of old homes and farmsteads and farm buildings that exist today in our area that are made of the wood of a chestnut tree. And some of them that have been well preserved, they'll have been infected with a worm, which makes a little hole in it. They call it a wormy chestnut. And there's a lot of that wood being salvaged out of farmsteads and old farm buildings to make picture frames and different types of small pieces of furniture. Highly prized because it's hard and rustic looking. Tend to have a grayish tint to it. But the folks that enjoy woodworking have done a lot with the residuals of the old chestnut trees.
Yeah, we built a house out near Hill. Dude, in English. We built a house out near Hillsville for this guy, and he used wormy chestnut all over inside, like paneling, and I mean, he spent a fortune on it, but
Yeah.
built some furniture in there. I mean, it was awesome. It was beautiful, but
It was hard to work. It was hard to work.
Yes.
But you know, the nuts that we're speaking of also include filberts and walnuts and hickory. But these various woods that come from these species are the more the harder wood. Oak is much. It's called a hardwood for that reason. It's a much harder, weathers well. You know, if you're constructing something on one of our farm buildings, you'd much rather have oak as far as the strength and the longevity of it than you would pine, because pine's considered a soft wood. There's a resort in the western part of Patrick County that has been on land that was bought by a French family, the Primos family, and they bought about 13,000 acres of mountain land, and they started with a timbering operation, then they went to firewood in about a 5-year sequence, and they built a lot of wood roads to the standards that would be suitable for an interstate highway. And people were, when they first started doing that, they thought they were, you know, going overboard. But their long-range plan, and you know, we'll talk about business plans. Tom talks about them in his classes. But their business plan was to use the wood that was on these mountainsides to begin to build some homes and structures and build roads and stuff in there. And what I was getting at, they've got a lot of houses built, or cabins, or lodges, what do you want to call them, built on these mountain edges, where they have long views off the side of the mountain that they're renting these places to folks from other areas. But this Primland, is a very pristine resort area. They have hunting and trout fishing, and they've established a big lodge, and they've got one of the 5 or 6 best golf courses in the state up there now.
Is that the one like at the top of that mountain there on 58 as you're heading through?
It is. You'll turn to the left off of 58.
Yeah. Okay, I was wondering what that was, and now I know.
Yeah, and Tom, that's the upper entrance, and that is got enough of expanse of land that they've got a lower entrance at the bottom of the mountain, down near what we call Kibler Valley. It's on the Dan River.
Okay.
But they've used a lot of the timber to build these homes, and during certain times of the year, the side of a lot of these homes is totally glass. And in the morning, like this time of the year, when the sun comes up in the east, it will reflect off of these windows in these homes. And I'm probably, as a crow flies, 18 or 20 miles from, well, probably only 15 miles, I guess, from where that house is, but I can see it. It looks just like a mirror from my house. And I'm sure they've got the equal type view back our way from the crest of that mountain. But one of those houses has got one room in it that has got oak paneling. It's got another room in it that has got cherry paneling. Another one has got walnut paneling, and there's another one that's got chestnut paneling.
Wow.
You know, and they've used these hardwoods very diligently throughout the construction of all these pristine resort type homes. They've even built a number of tree houses that you can rent for a weekend. You'll actually have a 2 or 2 or 3 bedroom house in the top of a tree that they'll use for these things.
Kremlin? You say Kremlin?
Do what? Kremlin, Primland,
With a P.
Kremlin.
Yeah, P-R-I, what, spell that again, P-R-I-M-L-A-N-D?
Yeah,
Okay, like
It's a
Kremlin.
resort.
yeah, it's a resort, yeah. And it's a little bit on the high end order. I think a normal, you can go up there at the lodge, they have a restaurant, and it's supposedly a 5-star deal. Typical meal for a couple in there, on a Saturday, probably costs you somewhere around $200. It's a little above my raising, so to speak, but they've used the land in a very conservation-minded way. They still hold pheasant hunts. They hold deer hunts. I was fortunate enough to go on a couple of pheasant hunts that was paid for by chemical companies. The first one we went on, there were 4 of us that went. We hunted half a day and had lunch. And I happened to get a glimpse of the ticket. And this was probably been 22, 23 years ago. And prices have gone up considerably since then. But the half-day hunt for 4 of us and the meal was $2,700. So, like I said, it's a little above my raising. But the point I'm trying to make, they have used these hardwoods very effectively throughout the entire expanse of this resort area. The lodge, I'm not sure what wood they've used to make it, but it's a massive, beautiful thing. So it's large enough that they have an elevator that carries you up to an area that has a telescope in it that opens the room that the telescope is in. The ceiling opens, and on clear nights they'll have visitors up there looking at the different constellations and things up in the sky with a high-powered telescope.
That's awesome.
As we talk about the next category of fruits, you've got a samurai, which is a 1-seeded seed, or sometimes a 2-seeded one. The single-seeded one is like an elm seed, and the 2-seeded, the one is one that all of you should be familiar with, is the seed of a maple tree. If you've ever noticed a maple tree, you'll get these little winged devices that will drop out of the tree and sort of flutter down like a wounded helicopter. And but that is the seed of a maple tree. We've got several other that are examples of 2-seeded that have 2 or more carpels. They're carrots and dills, and parsley are examples of that one. Another group of fruits that we talk about are aggregate or multiple fruits. These are things that if you don't spend some time in a class like this, you don't think of them. You don't consider them to be fruits. But these aggregate or multiple fruits have several ovaries, which are true fruits that are attached or contained within a receptacle or an accessory structure. Aggregate fruits that come from a single flower, a strawberry is an example. And it's a true fruit with many, many seeds. And there's a lot of difference in strawberry varieties. Some of the seeds are not very noticeable. And then occasionally you'll get some smaller sized strawberries that the seed is much more noticeable. I'm sure that some of you have gotten some strawberry jam, and it was probably made out of a highly flavored strawberry, but generally the highly flavored ones will have a little bit larger seed. So sometimes that seed in a strawberry jam can be a little bit objectionable because it's a little bit large and it tends to be a little bit dominant. Now, examples of multiple fruits that we talk about have many individual ovaries that are fused into a single structure. A fig is an example of this. How many of you are familiar with figs? You ever enjoy figs? You like figs?
Fig Newtons.
Yeah. And that's the way most people have been introduced or exposed to figs. They've never seen a true fruit of a fig tree. And they'll grow much better in the area where you guys are at Southside than they will here. We're a little bit on the cold. Our conditions during the winter are a little bit chilly for good fig survival.
Yeah.
If they're, what, Tyler?
I said no.
Hey, if you're growing figs here, you've got to put them in a protected area, usually on the south side of a building, to protect them a little bit from the north winds that we'll occasionally have in the wintertime. But figs will do well throughout the area where you guys are. A good friend of mine down in Halifax has got quite a few figs that they actually harvest occasionally and will sell in their produce market. But it's not a fruit or something that a lot of people have had any exposure to. If you didn't grow up around them, you won't know what a fig looks like. Mulberries are another example of a multiple druplet that is born on a fleshy receptacle. Mulberry is a wild creature, a wild little berry that is highly desired by a lot of the wildlife in our area.
Is that the thing that looks kind of like a blackberry in a way?
Looks a little bit like a blackberry, tends to be softened, grows on sort of a shrub type thing. Quite often they'll be an inch, 3/4 to an inch long.
Yeah, you usually find them out in the back country, growing on the side of the roads occasionally.
Well, they like marshy, damp areas. Then they could be on the side of the road, depending on the conditions there. But if you happen to be near a road or near a walk, you'll see the stains where they will drop and somebody will run over them or step on them.
Yeah, we have a few of them in my backyard.
Yeah, that's a mulberry. Yeah. As we transition from fruits, we're going to move into the description of what we talk about with seeds. And seeds are mature ovules that vary greatly in their size, shape, and structure, and the mode by which they are disseminated. And when we're talking about mode of dissemination, we'll make sure you understand what we're talking about. Let me ask you the question. What does the mode of dissemination mean? What would that mean to you? Anybody?
How the seeds are spread.
How the seeds are spread, Tyler, exactly. So we're talking about seeds. A dandelion or a milkweed is an example of a structure that has multiple seeds, and it has a downy filamentous type structure that aids in the dissemination of those. And what I'm talking about, have any of you ever picked off the seed head of a dandelion and blown it?
They go everywhere.
You're disseminating the seeds of a dandelion when you do that. The milkweed's very much the same thing. All right, there's another weed that is in my terms, in my eyes, a plague, just an absolute plague. That is very prominent in some crop areas. How many of you ever had any exposure to a cucumber seed? A cucumber.
Oh, Turner.
No, cucumber. What was that? They're what?
They're really like, they're small, round, sharp, prongy points that come out.
Yep.
Oh, I know what you're
Yep.
talking about. Oh my gosh.
I have actually seen sort of a joke type thing where they've been half a dozen, 10 of them, maybe a dozen, placed in a plastic bag on the shelf of a convenience store with a contents tag calling them porcupine eggs. But those things, the way that you just described it, they're sticky. They stick to you.
Yeah.
They'll get on your pant legs or your shoestrings. You know, that's a plague for us, but that's their method of dissemination. That if you ever cut one of those little sticky things, whatever you want to call it, in two, that is just the vessel that carries the seed. The actual seeds are inside of that. And I have read somewhere that, you know, I said that the cockaburr was a plague. Part of the reason it is a plague because in that little vessel that we call the cockaburr, it usually contains anywhere from 6 to 7, maybe 8 or 9 seeds, depending upon what way it was pollinated. And the nature of this particular plant is that all of those seeds will not germinate. Excuse me, I got a cough. Will not germinate in a given year. There may be a percentage of them that'll germinate the first year, following it, the establishment of that. Some of them may germinate the second year, some the third. So regardless of how diligent you are with your weed control, you still got the potential of having those things to reoccur. And if you ever let one to mature and form seeds, you've got the potential for 6 or 7 more years of those. So it's a real problem. But that's the way that those are disseminated, because that little burr type device will stick to things. And it's not only us. If any ever got them, noticed them on the hair of a cow, or a sheep, or a dog, or a deer. I killed a deer last week, and it had several cockaburrs on the hide of the deer. And those things will, you know, transmit those in all sorts of directions. How many of you know what a Spanish needle is? What? Spanish needle. The seed structure of a Spanish needle is very much like maybe a 1/2 to 3/4 inch pencil lead, brown little thing, but it's got 3 or 4 little sticky devices that'll affix itself to your pant leg or shoestrings, and the same thing with animals. And that's the method of dissemination for that weed.
So Spanish needle?
Mm-hmm. Spanish needle. There's another weed, the species called a beggar's lice, and it's a little flattened device that contains the seed, and it also sticks to your pant legs and so forth. These are just plague type weeds that I've cussed all my life because I don't like them. But that's the method of dissemination. As we talk about, we mentioned a while ago the maple, the little samurais that they've got the little wing structure that allows them to disseminate. They'll move by wind and be down. All right, when we go to talking about seeds, we've got different basic 3 parts of seeds. We'll talk about the embryo, and it contains the radicle and the plumule. We talked about this a couple of weeks ago. That's the 2 growing points that exist inside an embryo. We've got the cotyledons, which are the actual seed leaves that are held within a seed. Once it germinates, those cotyledons provide the nutrition for the establishment of the new plant. All right. That basically winds up chapter 6. Sort of quickly hit part of it, but there's there's a lot of content there that we need to be aware of. And I'm going to jump into chapter 7 if I can get the PowerPoint to pop up for that. All right, chapter 7 begins to talk about plant growth and development. And we're going to hit it in sort of a hurry because we're running out of time, but I'd like to get the majority of the high spots covered in the next 2 or 3 classes. So as we think about plant growth, that's the production of cells in an irreversible increase in volume or dry matter, and that's called biomass. And growth can be measured as an increase in the fresh or dry weight, or in the volume, length, height, or surface area. So that's what we're talking about growth. We're talking about the production of dry matter and an increase in the fresh or dry weight or the volume. So if we're talking about the growth of a seedling maple tree, assume that you plant one of those little wing devices and you get it to germinate in a cup on your windowsill. And you nurture that thing through the winter, and this spring it's up 3 or 4 inches high. You take it out once the weather danger of frost has passed, and you plant that in a spot in the edge of your garden or your yard where you'd like to have a maple tree. The growth that, as we refer to it or define it, is going to be the increase in the dry weight or increase in the length, the height, or the potential surface area of that seedling. So that's what we're talking about with growth. It's a result of cell division and enlargement that is brought about by the photosynthetic process. And we're going to talk about photosynthesis quite a bit as we move along. But as we talk about the growth and development, we've got a series of stages that plants go through. We talk about seed germination. We talk about the growth of vegetative organs and tissues. And we talk about the initiation and maturation of reproductive organs and tissues. Then we're going to talk about the fertilization, seed development, and the maturation of those seeds. And then the last phase that we talk about is senescence. And that's a term that I've found that is not common in the vocabulary of most of the folks that we've had in class. They don't know what senescence means. Right? You've heard it, Tyler?
Never heard of it.
You've never heard of senescence? Okay. We've had the senescence occur in the majority of the annual plants that grew this summer. The senescence has occurred in the last 3 or 4 weeks. That's the maturity, the maturation. It's the maturity of those plants, and it's going to be the fact that they were annuals. They were killed by the frost or the freezing temperatures you had. But senescence is the decline of a plant at the end of its growing season. Primarily refer to it as in the idea of annuals as we talk about it. But now some of your perennials and some of your biennials will go through a senescence process. Once that plant is matured and it no longer is effective as far as photosynthesis goes, it begins to go through what we call a process of senescence. It begins to age out, for lack of a better way of talking about it. So senescence and death are the last two. So we talk a little bit about how a plant's going to grow. In dicots, and what's a dicot?
It has 2 cones, 2
It's a plant that has 2 seedlings. Okay. But in a dicot, we have vegetative buds that occur at the shoot tips and contain these meristematic cells that we talked about before. And those meristematic cells are capable of producing millions of cells as the plant grows and elongates. And this is where division and elongation and expansion occurs, which causes the extension of shoots, the shoot growth. You also have these meristematic cells or tissues at the tips of roots. And they're just behind what we call the root cap. The root cap protects those meristematic cells as the root elongates. It causes the thickening of trunks of dicot trees, and it will eventually produce what we call the vascular cambium. In mature plants, a vegetative apical meristem can produce meristems and produce floral parts needed for seed production. So meristematic cells and meristematic tissues are the points or the sites of growth. It's where cell division and elongation takes place. It's the point of growth. And if we're talking about dicots, it's going to be the apical meristem. Apical means the top. So that's apex, right, Tyler, exactly. So that's the point in which your plants begin to grow and elongate going upward. Now that's what we're talking about a dicot. A monocot is a different animal. It's different, particularly when we're talking about grasses, because the meristematic region on those is lower. It's down just above the ground level, which enables you to be able to mow your grass. If it was on the top, like all the dicots, you'd mow it off, and essentially you'd kill your grass. But grasses are different. Going to skip through a little bit of this stuff. We're just not going to have time. All right, as we talk about the growth, it is going to be controlled and affected by a number of plant growth regulators, naturally occurring plant growth regulators, and they are what we also call growth hormones. But they're naturally occurring in every plant that we have. And what we're talking about there are auxins, gibberellins, cytokinins, and then another plant growth regulator called ethylene. But these hormones are the ones that most greatly affect plant growth and development. The environmental factors like temperature and light can function as signals for different stages of the development of plants. And many of the measures that we use to control plant growth and development ultimately work by activating and deactivating your gene transcription. And we're not going to get into that because it gets pretty technical, and I don't think we need to do that in this introductory class because of time restrictions too. But there's a lot of information there if you want to get into it. It gets into pretty technical plant physiology. I spent an entire semester on plant phys at Tech, and it got a little bit hairy. But it contains a lot of biochemistry and genetics and so forth. But we won't go there for this class. All right, as we talk about the light that affects plant growth, the sun is the source of the energy for photosynthesis. And the wavelength, the sun has a wide array of degrees of irradiation. But the visible light that affects plant growth, it's also called the photosynthetic active radiation, is in the range between 400 and 700 nanometers. And that's something that'll appear on the test, I guarantee it. So you need to know what the photosynthetically active radiation is between 400 and 700 nanometers. Now, the 400 is in the blue range, and we'll talk about that a little bit more. But radiation is lost by absorption, and it can be refracted, or scattered, or reflected back into space. And through those processes, it'll reduce the amount of light that's available for radiation, for photosynthesis. Light is a controlling factor for all plant growth and development. And the best light that occurs for all of these functions is light that comes in at a 90-degree angle, from, in other words, straight down. That's why the plants in the area of the equator are the type that they are. They get the maximum amount of sunlight throughout the entire season. The sun will move a little bit to the north, then it'll move back a little bit to the south, but it's still basically directly over the equator. So the angle of incidence that we talk about is the greatest amount of light striking over a given area. We're about to approach, well, let's see, it's about 3 weeks, 2 weeks, 3 weeks, when we're going to reach a point as far as our area of the world is going to get the least amount of light or photosynthetically active radiation, and that's going to occur on about the 20th or the 21st of December. They varied a little bit, but that's when we think of it as being the beginning of our winter. Our days are actually going to get shorter until we get to that time period. And it seems a little strange to me, it always has, but the scientists have been able to explain why. But we're in our point in our season right now when we are getting approaching the least amount of photosynthetically active light that we get in a given year. And once we pass this thing we call what's going to happen on the 21st of December?
Well, if it was 2012, it'd be the end of the world.
No, we're not going there, Tyler. That's not what we're talking about.
Like the winter.
Get back in track. Go ahead.
Is it winter solstice?
It is the winter solstice, exactly. And that's the shortest day of the year that we have. And once we pass the winter solstice, our days begin to get longer, only by a minute or two, both on the day the time that the sun comes up and the time that it sets. But I happened to look one day last week, and we only had 10 hours of daylight. And in about 3 weeks, we'll only have about 9 hours and 20 or 30 minutes. I can't remember exactly what it is.
I didn't realize we were living in Alaska.
No, Alaska's much different than that.
Isn't something like 6 weeks of straight night?
I'm not sure exactly the amount of time, and it depends on where you are. But they'll have a period of about 6 or 8 weeks when the sun does not come up.
Yeah, because I remember when my girlfriend was still living in Alaska, she said that there was a lot of cases of severe depression during those times.
Yeah, and they're blaming it for that, but I'm not sure what. But that's not that's what we're talking about. They don't have any sunlight during that period of time, and it's extremely cold. Now, on the other side of it, when we get to the summer solstice, they have essentially a 24-hour day.
That must be fun.
It's, you know, the light, it will be low light intensity, but you've heard of the midnight sun, and that's basically what happens. One summer I had an opportunity to travel to Nova Scotia, and it's far enough north that at 10:30 or 11 o'clock, the sun was still up in the middle of July.
That must have been fun getting used to adjusting to.
Well, we didn't stay long enough, so we did much adjusting to it. That's just some of the extremes of the things that Mother Nature provides for us. And we've talked about this, I think it was in another class or two, but we were talking about the growth of extremely large pumpkins when we were talking about the state fairs and so forth. Until a few years ago, the largest pumpkins that were grown were being grown in Nova Scotia because of the extended daylight. They had real rich soils. Nova Scotia grows a lot of potatoes, and they have a real thick, heavy loam soil, very highly productive. And they would start pumpkins early, this particular variety, maybe only one plant in the size of the room in which we are, but they would start with a little greenhouse structure over that plant and let it become established. And when the temperature changes to frost had passed, they pull that little greenhouse structure off. And because of the long day, that plant was much more productive than it would be one here. So, and we're out of time. Okay, we'll pick this up and try to bounce through this chapter pretty quickly next time, and then on Monday. And then my hope is to try to have another test on about 2 chapters before we get to the exam sessions. Give you guys another opportunity for another grade. So, all right, y'all have a nice day. Stay in touch.
Okay, bye.